We have the following questions under complex numbers to attend to. The first one says we should find the sum of 3 minus I minus 1 plus 6I plus minus 2 plus 8I with these options. Then the second one says we should solve the division 8 plus 7I divided by 4 plus 2I with the options given here, A, B, C, D. Then the fourth one, given that A minus, then the third one, given that 8 minus I multiplying 10 plus 3I is equal to X plus YI. Find the value of X and Y. For the first one, we have 3 minus I minus 1 plus 6I plus minus 2 plus 8I. So the first thing to do is to open this bracket. Opening this bracket, we are going to have 3 minus I. Minus times 1, we are going to have minus 1. The same here, we are going to have minus 6I. Opening this one, plus times minus 2, we are going to have minus 2. Plus times plus 8, we are going to have plus 8I. So, at this point, we'll subtract real parts and imaginary parts. That's going to be 3 minus 1 minus 2. Then we'll focus now on the imaginary parts, which is minus I for this first one, minus 6I, then plus 8I. 3 minus 1 minus 2 is 3 minus 3. Then minus I minus 6 is minus 7I. Then plus 8I. With this, 3 minus 3 is equal to 0. Then minus 7I plus 8I is equal to plus I. So 0 plus I, it's equal to I. So for this first question, option B is the correct answer. 3 minus I minus 1 plus 6I plus minus 2 plus 8I is equal to I. For the second one, solve the division 8 plus 7I divided by 4 plus 2I. Number 2, we have 8 plus 7I divided by 4 plus 2I. Remember, while we are looking at the division of complex number, we said since we have two independent terms in the denominator, we cannot do direct division. And so we need to rationalize the denominator by using the conjugate. So since this is 4 plus 2I, the conjugate of this is going to be 4 minus 2I. So this will be equal to 8 plus 7I divided by 4 plus 2I. We'll multiply this by the conjugate, both in the numerator and in the denominator. That is 4 minus 2I divided by 4 minus 2I. And this implies multiplying 8 plus 7I by 4 minus 2I. Then we'll divide by 4 plus 2I multiplying 4 minus 2I. Opening this up now, we are going to have 8 multiplying everything here. 8 into 4 minus 2I. Then we have plus 7 4i multiplying 4 minus 2i. All of this will divide 4 into 4 minus 2i, then plus 2i into 4 minus 2i. With this, we are going to have 8 multiplying 4 giving us 32. 8 will multiply minus 2i to give us minus 16i. 7i multiplied by 4 will give us 28i. Then 7i will multiply minus 2i to give us minus 14i squared. We'll divide this by 4 times 4 is 16. 4 times minus 2i is minus 8i. Plus 2i times 4 is going to be plus 8i. Then plus times minus is minus. 2i times 2i is going to give us 4i squared. So at this point, we will have 32 plus minus 16i plus 28i is going to give us 12i. Then minus 14. Remember, I squared is equal to minus 1, so we'll multiply this by minus 1. Then we'll divide this by minus 8i will go with positive 8i, and we are left with, in the denominator, 16 minus 4. Again, remember, I squared is equal to minus 1, so we'll multiply this by minus 1. Right? This is equal to 32 plus 12i minus 14 minus 1. That is minus 14 times minus 1 is equal to 14. So we have 14 here. Right? We'll divide this by 16 plus minus 4 times minus 1 is equal to 4. And that's equal to 32 plus 14. We have 46 plus 12i. Divide by 20. So what we have here as a solution for this particular division is 46 over 20 plus 12i over 20. Reducing this fraction, the common factor here between 46 and 20 is 2. So reducing 46 by 2, we are going to have 23. Reducing 20 by 2, we are going to have 10. So we have 23 over 10. Plus the common factor between 12 and 20, we have 4. 4 will enter 12 3 times. 4 will enter 20 5 times. So we have 23 over 10 plus 3 over 5i as the solution to this division of complex numbers. So 23 over 10 plus 3 over 5i is the answer. And that corresponds with option C, 23 over 10 plus 3 over 5i. The last one we are going to solve is number 3, that says, given that 8 minus I multiply 10 plus 3i is equal to x plus yi. Find the value of x and y. So we are going to find the product of that complex number, then we'll get to know what the value of x and y are in that particular question. For the third question, we have 8 minus I multiplying 10 plus 3i. Right? So since it's multiplication, we are going to have 8 multiplying everything in this bracket, that is 10 plus 3i. Then we use minus I to multiply 10 plus 3i. So opening this up, we are going to have 8 times 10 giving us 80. 8 times 3i, we are going to have 24i. Minus I times 10, we are going to have minus 10i. Then minus I times 3i, we are going to have minus 3i squared. So we have 80 plus 24i minus 10i is 14i. Minus 3i squared is same thing as 3 into minus 1. Remember, I squared is equal to minus 1. So that we have 80 plus 14i plus 3. Minus 3 times minus 1 is equal to plus 3. So adding the real part, we are going to have 80 plus 3 giving us 83. Then we have plus 14i. So in answering that question, remember we did say that a complex number is of the form z equal to x plus iy or yi, either way. So if you have this as a complex number, this is our real part, while this is the imaginary part. So from this solution, you are seeing that the real part x is 83, while the imaginary part y is equal to 14. So based on the question we have above, x is equal to 83, while y is equal to 14. So we have here x equal to 83, y equal to 14, corresponding with option B. Given that 8 minus I multiplying 10 plus 3i is equal to x plus yi, the value of x is 83, while the value of y is 14. So this is how to solve for complex number, whether it's multiplication of complex number like we have it in number 3, or division of complex numbers like we have it in number 2, or addition of complex numbers like we have in number 1.